Well, my friends, I'm back again. I got Jamie on camera today. We're going to talk about a product that deserves more awareness. Literally walked into a shop just the other day. They had machine spindles sitting for over 24 hours while they measured extremely complex parts. Think about the lost time, the downtime, the lost money and resources. This is the conversation we're going to have today with Jamie. Jamie, I exaggerate a little bit, but I think it's important for them to understand, the folks out there, 5 minutes, an hour, 5 hours, 24 hours, like I did see in a machine shop the other day. You guys at BLUM have come to step in and say, we have a solution for you that can give you a go, no-go on if that part can be done and shipped off to the next area, or if we need to make maybe a couple of changes in our program.
Right.
Let's talk about the demo that's running here and how this probe works for everyone who's extremely curious for their machine shop having downtime.
Sure, thanks, Tony. We're doing something a little different than what we see in a lot of demos. In this case, we've got our TC64 probe, and we're doing a scanning demo. So instead of just single point touching with a probe, we're actually scanning the part like you've traditionally seen on a CMM. Now we're doing it inside the machine. So we essentially call it a go, no-go gauge, just for the fact that you need to know before this part comes off, is it a good part, bad part? If it's a good part, get it off. Let's get the next one running, making chips, making money. If it's not a good part, let's stop. Let's figure out what's wrong, figure out what we need to do to make good parts. So traditionally the probe's always been single point, and that's a digital signal. So it's a 0-24 volt like we've always had with our probes. We convert this to analog, and now we're measuring the deflection of the stylus. So that's where we get, our tagline with the Digilog technology. It came from this. It came from this probe.
Yeah, very nice. If you could think about when I always step into machine shops and people think they have it all figured out already, or they know nobody knows my machine shop better than me,
Sure.
Right? So sometimes we walk in and go, I'm here to help. And we're doing that on camera to thousands, if not millions of people around the world right now. That's why we create these videos. If you could describe to people out there who are kind of stubborn like me,
Yep.
Where this best comes into play inside their machine shop, if you were to walk in, where do you think this is best utilized? I mean, me personally, I've been a machinist. I know that when the machine stops, we're losing money, and having something like this. But I want to hear it from you, because you are the expert on this product, understanding perfectly when you walk in where this can help the folks out there watching.
Yeah, you're right when you bring it up. The customer always, they know their product, they know how to machine it, they know their shop the best, and they're right. They are the expert of their shop. They know what they're doing, they know their process the best, but that's also why we can't expect them to be the expert of what we do.
Or of everything.
Of everything.
There's a lot going on.
Yeah, we've talked about it before, and I've said you've got to reach out to the experts in the field. I don't care if it's when you're buying the machine, when you're buying your probing system, you're buying a laser, you're buying your tool holding, whatever. Reach out to the experts. You can't be an expert on everything. I'm not an expert on tool holding, but I am an expert on this. So reach out and have this discussion. In this case, we look at unique products where we're machining, maybe it's a 3D profile, and that's really difficult to inspect when you're doing a single point inspection with a probe. If you've picture a blisk, trying to inspect that blisk in the machine is very difficult with a single point. The more points you take, the longer it takes to inspect it. The less points you take, the less likely you are to actually catch a problem. If there's a miscut in there or something, you might skip over it by not measuring as many points. In this case, we can come in, we can check that profile, we can scan it, and we're getting a go, no go. So we'll take a master part, we'll program the tool path with that master part, we scan it, we'll see exactly what a good part should look like. After that, after each one comes through, quick scan. Is it good? Is it within the limits? If it's outside the limits, we're going to stop. If it's within the limits, we're going to continue on. But that's not to say we're doing that because we know your process. You know your process, you know where to put it. We just want to make sure you're aware of the technology that can do it.
Yeah, I think that's important to understand as we educate an audience on how this technology works. It looks like it's moving quite quick to me. And when I look inside the machine, is this product, is this the fastest on the market? Is this, how does this,
Yeah.
I'm going to go back to the original term that I used just for redundancy, Jamie, and I apologize. I'm not articulating perfectly for multiple different adjectives to describe the speed, but it just looks like it's moving quite quickly, a lot quicker than I see a lot of the CMMs out there. So
Yeah.
I guess my double question is, do we still use a CMM afterwards, which we should probably do, right? But it also looks like it's moving really quickly inside the machine when I think about the downtime in combination with, making sure that it's a good part.
Yeah, you're exactly right. It is moving quick. And we've actually got it slowed down a little bit for this demo because when we first programmed the demo, it was too short. It happened too quickly, and we first looked at it, we're like, people are going to ask to see it over and over, so we slowed it down a bit so you can watch it. But in real time, when you're running production, it's got to be quick. We know that when you're probing in the machine, you're taking away from machining time. So we need to probe as quick as we can. That being said, we'll get it in the machine, out of the machine. We're not going to replace your CMM. You're still going to want to do your first part inspection on the CMM. And if normally you check this part every 15 parts, we're not saying stop doing that. We're just saying this is going to confirm for you that parts 1 to 15 or 2 to 15 are going to be good.
Right.
Because we've confirmed it on the machine. Still do that inspection. Once you see the reliability between the probe and the CMM, you know it's consistent, you know the results you're getting are good, you might want to stretch that out. You can go a little bit longer, but you also don't need the machine down while the part's gone to the CMM. You can be confident in your process because we're checking it in the machine. If it's something unique, great. We're going to find out before it comes off the machine if it's good or bad, and then you don't have to try to worry about how am I going to put this back on? How am I going to clamp it? How am I going to index this part? That's everybody's worst nightmare. And those are the things we're trying to avoid. We want you to be confident when this part comes off, it's a good part. We're never going to convince anybody in the quality assurance world that we can inspect a part on the machine that we made it on. We're not trying to do that. It's not a fight we're going to win. But you made it on this machine, you made it accurately, you can inspect it accurately on the machine. So
thank you for taking away some of our nightmares.
Right.
And I should have taken your advice when I was asking the question, slowed my brain down a little bit because my mouth is moving too quickly. All right, last question I have for you, Jamie, as we bring this all to a close is, sometimes technology, we don't adapt it because we think it's complicated or it adds to something that takes us outside of our comfort zone, even if it is easy. How easy or complicated is this to adapt to my existing machine?
Yeah, you know what? Now's really the time, more than any other time, that we've got to get out of our comfort zone. We know what's going on in our industry right now. And if we stay in our comfort zone, I think we know where we're headed. So we got to get outside of that comfort zone and try different things. If we're not doing different things, that's one of the reasons why we brought this to the show, to expose it to more people. It's a product BLUM's had for a long time, but I think whenever I speak about it with customers, they generally don't know it exists. So it gives them the opportunity to look at their process a little bit differently and how they're going to do things. And we've got to make that change, especially here in Canada. It's got to change so we can continue with our manufacturing the way we have been. But developing it and programming it, not a problem. Your NC guys, they program a tool path. You're programming a tool path with this probe. So this probe's going to come in, it's going to follow the tool path, and ultimately what it's doing is just loading up the stylus halfway to its range. And if there's extra material, it's deflecting more. If there's less material, it's deflecting less. So that kind of simplifies how it works, but
making our jobs easy.
Yeah, it's the best way for people to understand. So,
Jamie, I don't want you to drop my microphone, but the way you described leaving the comfort zone and the necessity to do that, that was a mic drop moment. I'm not sure if editing can do something about that, but really well said. Jamie, thank you so much for your time today. Thank you for educating myself and the audience on this incredible product. As a machinist myself, I certainly could have used this. I had so much downtime. I know the average at one time around the country was more or less 40% of uptime. What if we can get that to our 80%, 90% where we need to be? That's where the machines, that's where BLUM comes into play, and that's where the folks out there watching can truly make money and compete globally. So thank you so much, Jamie. I really appreciate you.
Thanks for coming, Canada, Tony.